Hi everyone, I hope you're okay and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the ninth question from the preliminary examination which was written in the year of 2023 at St. Mary's School in Waverley. Please do expect a total number of 12 videos since the question had 12 questions in total. That means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel by just subscribing. Okay, consider the diagram, the graphs of f of x and g of x. We are given the graph of f of x, g of x, and that of p of x, né? And they are sketched below. Point A rather is a point where the graph of f of x and g of x intersect. The point 1 over 9 and 2 lie on the graph of p of x. Okay, firstly they want us to determine the domain of the graph of g of x. Where is g of x is our parabola, né? Okay, we'll find our domain, guys. Our domain, we'll find it whenever everything under the square root is just greater than 0. So 13 minus 2x is greater or equal to 0. Are you together? Because we cannot have our expression inside the square root to be negative. Are you together? Because whatever that inside the square root will be non-real, if and only if it is negative. So everything, guys, under a square root has to be positive. Are you together? And obviously we have our x value there. So making our square root greater or equal to 0 will help us to find our domain. So this will be just 13 is greater than 2x, greater or equal to 2x. Then, or rather, let me write it like this. Negative 2x is greater or equal to negative 13. If I divide both sides by negative 2, I'll have x on the left-hand side. But remember that, guys, I'm dividing with the negative number. So the sign of the inequality has to change. So I'll end up having 13 over 2. So this is my domain. The domain of my graph, we can say x is less than 13 over 2. Or you can simply write it in interval notation. Y is an element of negative infinity until 13 over 2. Okay, and then now they want us to write down the equation of p of x. We are given, guys, p of x in a form of unknown variable b. There's p of x being equal to the log of x base b. Né? Okay, the value of y is 2, and then I have log of x, that's 1 over 9. Né? For me, guys, to find the equation of p of x, I just need to find the numerical value of b. Are you together? But I cannot find the numerical value of b if I do not substitute an extra point on the curve. I was told that this point belongs to p of x. Are you together? So how can I remove this logarithm? Because the aim, guys, is to isolate b. Now, how can I remove the logarithm? I'll take b to the other side. It will be the base, and whatever that was here will now become an exponent. And then I'll have 1 over 9 over there. And then I can take square roots on both sides. I'll find that b is equal to plus or minus 1 over 3. But the condition, guys, for logarithms, our base cannot be negative. Because if you have a negative base, it simply means that this entire thing will be undefined. Are you together? So hence, the base is basically equal to a third. And therefore, p of x is equal to the log of x base 1 over 3. Others, guys, may prefer to write this equation like this: negative log of x of 3. You can write it like this or like this. It's still okay. That's one and the same thing, né? So the equation p of x is just equal to the log of x base 1 over 3. Now they want us to determine the equation of h of x if h of x is the inverse of p that has been translated 4 units up. Okay, firstly let's find the inverse of p, guys. Né? If p of x is just equal to the log of x base 1 over 3, for me to find the inverse, I need to reflect the graph on the line y is equal to x. Are you together? Basically, this means I must just interchange both x and y. I'll have y on the other side. This is equal to the log of y base 1 over 3. Né? The aim of finding an inverse is to just isolate the log. How can I just isolate y rather? But how can I isolate y? By making 1 over 3 the base on the other side. I'll end up having 1 over 3 to the power x is just equal to y. So therefore, the inverse of p is just equal to 1 over 3 to the power x. But h of x, guys, is just the inverse of p that has been translated 4 units up. So therefore, h of x will simply be 1 over 3 to the power x plus 4. This will be the graph of h of x. Then now they want us to determine the coordinates of point A. Where is point A? Or point A is the point of intersection of these two graphs. Okay. How can we find the intersection, guys? By simply equating the two functions and then solving for x. Are you together? Point A is the point of intersection of g of x as well as f of x. Are you together? G of x is just the square root of 13 minus 2x. This is equal to negative x plus 5. How can I solve x over there, guys? By simply squaring both sides. I'll end up having 13 minus 2x on the left hand side. On the right hand side, I'll have x squared minus 10x plus 25. Make sure everything is in standard form. I'll take these two to the other side. I'll end up having x squared minus 8x, and then 25 minus 13. 25 minus 13 is just 12 plus 12. This is equal to 0. I'm looking for the factors. For the factors of 12, that's when I add will give me 8. That's just 6 and 2. The sign there is plus. That means my brackets will have the same sign, but not just any sign, guys. The sign of the middle term. Minus and minus. Therefore, x is equal to 6 or x is just equal to 2. Are you together? So A has an x value of 2. Then let's just go and find the corresponding y value. If x is equal to 2, let's just use f of x. If x is equal to 2, what is the corresponding y value? The corresponding y value is just equal to 3. So the coordinates of point A, I have 2 and 3. And then now, guys, I'm told that on the axis provided, redraw a rough sketch showing all the intercepts with the axis of the inverse of f of x. For me, guys, to draw an inverse function, I just need to know the structure of my original function. Né? For g of x, let's start with g of x first, guys. Né? It had, g of x had an x-intercept of remember that whenever you solve for x, guys, y is equal to 0, then you solve for x. The value of x over there was just equal to 13 over 2. So since my x-intercept was there, that simply means my y-intercept will be at 13 over 2 as well. Are you together? And then for the y-intercept of the original graph, y-intercept, you must make x 0. You'll be left with the square root of 13. That means I have positive square root of 13 as my y-intercept. Therefore, the x-intercept of my inverse will also be the square root of 13. So the graph will just move like this, guys. This is my rough sketch. Are you together? The rough sketch of my graph will just move like this. I'll simply have 13 over 2. Actually, it should be like this. Why am I saying that, guys? Remember that we're the positive x-intercept, right? So the y-intercept of the inverse should be positive as well.